Welcome, everybody. We're just going to give it a few minutes for everyone to be able to come into the meeting. Okay, welcome. I'm going to get started with introductions, and hopefully everybody else will filter in before we start with the presentation. So welcome to Cost-Effective Methods to Achieve Local Law 97 Compliance, another class in our Local Law 97 series. For those of you who don't know me, my name is Rebecca Poole, and I'm the Director of Membership and Communication for the Council of New York Cooperatives and Condominiums. If your building is not currently a CNYC member, we hope you'll consider joining us next year. We've been providing advocacy, information, and education, such as this webinar, for co-ops and condos since 1975. We're really pleased to have Steve Shwarzbaum of Dual Fuel with us this evening. We reached out to Steve to present this class because several of our members have used dual fuel to install energy management systems or to change from oil to gas and have managed to achieve compliance for 2025 and 2030 with a minimum outlay of cash, and they're also saving on operating expenses. So we're very grateful he agreed to speak for us this evening. Dual Fuel is an integrated service provider of cost savings and energy efficient solutions. They're committed to providing the best quality to their customers, whether it's an equipment upgrade or a full-blown system revamp. They've got you covered. They're licensed master plumber, general contractor, NYSERDA real-time energy management system and service provider, Con Ed CNI partner, Con Ed multifamily partner, and Energized New York City PACE contractor that provides oil to gas conversions, combined heat and power systems, boiler installations, building, repipes, heating controls, boiler monitoring, energy supply, oil and gas, energy efficiency retrofits, and emergency service to residential and commercial buildings. Before we start, just a bit of housekeeping. What we're going to try and do this evening is answer your questions as we go through, because we want you to be able to get everything you need out of this webinar and be able to figure out how to get your compliance going, going forward. So thank you for attending. And Steve, I'm going to turn the floor over to you.
Awesome. Thank you for the introduction, Rebecca. That was a mouthful. And thanks for inviting me, and I'm happy to be here. So as we go through, if you guys have questions, feel free. I think you could raise your hand within the webinar and Rebecca could call on you. So Dual Fuel was founded in 2012. We're a mechanical contracting company. We specialize in heating and energy efficiency. Local Law 97, obviously, for the last few years has been a very hot topic. And it's heating up as we get closer to 2024. So our geographic area that we cover is predominantly New York City, 5 boroughs. We also do work in Westchester and northern New Jersey. We have our boiler control platform, which is called Axon, in about 250 properties right now, which represents about 10 million square feet. We service about 600 heating plants annually. We have worked in over 1,000 buildings. Company is about 95 people right now, and we have several licenses in-house. So master plumber, oil burner installer, general contractor. And a lot of the work we do also is able to qualify for rebates. As Rebecca mentioned, there's a few different rebate programs that are available. And we try and participate in all of them that we know about. So we've been, successful in obtaining over $3 million in rebates for our customers over the last couple of years, which is great. So integrated energy services, right? This is kind of what Rebecca said at the beginning with the introduction. The concept of, dual fuel and what we want to do is we really want to bridge the gap between your equipment, the installation, the servicing of it, the operations of it, if it's running efficiently, if it's running reliably, and really try and bring that all together into a single platform, right? So, we do emergency service, we do installations, we do repair work. We also do boiler control, so we're able to actually see what's going on in your buildings real time, right? So if your boiler's supposed to be running and it shuts off, we're finding out about that instantly. So that's the integrated part, right? And the goal is maximize comfort and minimize cost, right? That's the whole concept of what we're here to do. All right, so Local Law 97. Some of you might know, others of you might not know, but in typical pre-war buildings, which I imagine, the majority of you represent pre-war buildings, heating systems are about 80% of the common area energy, right? So you have some hallway lighting, maybe you have an elevator or two elevators, not so much amenity space. So when you look at local law 97 and when you look at complying with local law 97, you can't really get past the heating system because that's where the vast majority of the energy is going. Obviously, there's a lot of talk now about electrification and decarbonization and other pathways. And for some buildings, that's a good solution. And for some buildings, they want to, spend the money, but it is very expensive, as I'm sure you guys know. And I think you might have covered in earlier webinars. So we really, you know, we really like to bring all the options to our customers, and we do electrification as well. But a lot of times you're able to kind of get where you need to, especially for 2024 and 2030 with the existing systems that you have and not doing, major upgrades. So the timeline for local law 97, going back to 2020 is when they started with having to post the grades in front of buildings. In January 2024 is when the emissions limit went into effect. Okay, this is cool. So Daniel, I see your question. Please cover efficiencies with steam heat. No problem. So the emissions limit take effect, right? Which means 2024 is the first year where they're actually going to be tracking your usage and, comparing that to what your emissions limit is as per local law 97. And then we're all going to see what happens in terms of the fines and, how the city actually rolls that out, right? So May 1st, 2025 is when the filings are due. Then, of course, in January 30, there's a second level of emissions reduction, which is very significant and is a 40% reduction compared to the 2024 levels. So I think, and Rebecca might even know better than me, but I think something like 15 to 20% of buildings are not in compliance come 2024. And that number jumps to about 75% of buildings come 2030. So, I imagine for the people who are here, you might be one of those buildings that's not in compliance in either 2024 or 2030. So hopefully what we cover tonight will help you get there. All right, this gets like a little bit technical, right? This is kind of the background data of, how number 4 oil is rated, how number 2 oil is rated, how natural gas is rated. What I want you to just look at this slide, which we just covered, but this multifamily, which is what covers your building, you could see there's a 39.7% reduction, right, from 2024 to 2030. So again, while most buildings are okay for 2024, there's a lot that are not okay for 2030. And a lot of people are asking us, what should we do? Should we electrify? When should we start? We're in a good position for 2024. We're not in a good position for 2030. I think it's a hard answer. I don't think it's blanket, but I do feel like as we get closer to the deadlines, right? And we're seeing it now for people who have 2024 issues, but I think it's going to get much crazier come 2030 because there's so many buildings. There's going to be a big rush of people who need to get work done. And unfortunately, there's a limited amount of contractors and, people out there who are able to provide the services. And I think that, from a pricing perspective, if I'm sitting, in your guys' shoes and I'm sitting on a board, I don't really want to be getting jobs priced out when every single contractor is super busy and has amazing amounts of work and a huge backlog. Because at that point, you guys really aren't in good negotiation position and kind of the contractors have all the pricing power. So I think for boards, have an understanding of where you're at now, have an understanding of where you need to get to, have an understanding of what those costs are, and try and do them as soon as you can. Because the reality is all the things that we're going to cover tonight not only are going to reduce your emissions and get you in a better position for 2030 and 2024, but pretty much every single one of them has a very good payback on the investment, not even taking local law 97 into account. Some things like boiler controls for certain buildings have a 1 year payback. Gas conversion, some buildings might have, a 4 or 5 year payback. So you're looking at really good financial, metrics just on the project itself.
Right.
And I think it makes sense, to plan accordingly.
I'm just gonna jump in quickly in terms of getting the work done in advance. So meeting that I was at today, they were talking about how the incentives are changing, right, all the time. So the other thing to keep in your mind is an incentive that's available today that maybe can help reduce the cost of your project may not be available in 5 years or 4 or 5 years when you're looking to do the work. So that's another thing to keep your eye on, I think.
Yeah, that is sure. They change every year, and sometimes they even change during the year. So what can you do? All right, so you don't have to panic. It's okay. Um, in my mind, this is what you have to do, right? And you don't have to do anything, but from a, from a responsibility to your building perspective and from a, what makes sense financially. Oil to gas conversions, right? Again, we're keeping in mind that 80% of your emissions are coming from your heating plant, right? So oil to gas conversions is the best thing you could do in terms of emissions reduction for buildings that are on oil. Advanced heating controls are very, very effective. Heating distribution upgrades, really important. And just making sure that your equipment that you have is running well. So we'll go into each one of these now in a little bit more depth. I didn't want to do a long, boring presentation. So there's really only a couple slides on each one. And, we can go through the oil to gas conversion section and then stop. And if people have any questions about it, or they have questions about boilers or anything, we can kind of take a few minutes to do questions. Okay, so number 2 oil has 28% more emissions than natural gas. Okay, so this doesn't take efficiency into account, right? Doing a gas conversion is not really considered like an efficiency upgrade. You're connecting to the same piece of equipment, right? So on the left, and this is a job we did at a building in the Bronx, 1915 Morris. So on the left, you have an old boiler with a burner. That burner was running on oil only. On the right, it's the same boiler room. It's a new boiler and a new burner, and that burner is dual fuel. So it's able to run on both oil and gas. Without any increase in efficiency, right? Like even just assuming that the system will operate exactly the same, you're going to reduce your emissions by 28%. One other thing that I would point out, are you guys able to see my cursor by any chance or no?
Sorry, do you want to share your screen, Steve,
No,
instead of
I'm just trying to put my cursor because on the right side of the burner, I'm not sure. Yeah,
is it here?
exactly. Right there. Yeah. So you see that's called linkageless controls. So that's an upgrade to a burner where, the old style burners actually have linkage arms, which will like move the burner, the gas and the air and the oil ratios, which was like an old mechanical system. Newer burners you're able to get with actuators, and basically you're able to program in the exact positions that they should be in at different firing rates. So that's also really helpful for emissions. So for this job, you can kind of see, the work that we do. Also what it looks like to do a boiler replacement and a gas conversion. Um, and I can go through if you guys want. Would it be helpful to like kind of run through the process of an oil to gas conversion, like timeline, things like that?
Do you want to um do people want to throw an answer into the Q&A if they're still on oil and considering switching to gas? Maybe we can determine it that way.
Yeah.
Or raise your hand. Is there anyone here that's still on oil? Yes. Don't need this. We have one yes. All right, we have 3 yeses. So we'll go through. All right, we have 4 yeses.
Okay.
Okay.
That sounds good. Hey, Carl. Um, okay. So basically, oil to gas conversions, the first step is you basically have to file an application with Con Ed to determine if there is enough gas available in the street for your building. Once you do that, you kind of start a process where you end up having a meeting on site with Con Ed, which is called a point of entry meeting. You determine where the gas is going to come into the building. And then from then, you're basically doing all the internal work. So, you're running your gas line, you're replacing the burner. A lot of times you need to replace or reline your chimney to make sure that it's code compliant. You have to do a lot of miscellaneous work in your boiler room to make sure that it's code compliant up to recent DOB codes. And then usually about 6 months to 9 months after you first meet with Con Ed, they'll actually open up the street and bring new gas line into your building. At that point, you're getting all your sign-offs and you're going through final inspections with Con Ed to get the boiler running on gas. So the entire project usually takes about 9 to 12 months from start to finish. And, us and other contractors similar to us will typically handle the whole project for you. We can work directly with the engineers. The engineers will do the filing. We handle all the Con Ed coordination, the DOB coordination. So it's really kind of like a turnkey operation. And that's the process for a gas conversion.
And are there still areas in the city where you can't get the gas, or specific neighborhoods, or everywhere is okay now to get the
Yeah,
gas
so
in?
most places are okay. You do have to file. There were pockets, for example, in like Washington Heights that had a really difficult time getting gas, but kind of did like a major main infrastructure upgrade over there. The vast majority of buildings are able to get gas. From time to time, you might have kind of like we're doing a job right now on East 65th Street, and the building actually runs from 64th all the way to 65th. The building ideally wanted to bring the gas on East 64th, kind of doesn't have a main there. So kind of making them bring it on East 65th. So sometimes you'll run into things like that, but for the most part, um, 95% of buildings roughly are able to get gas. Now, to give you a sense of local law 97, right, and how a gas conversion actually impacts. So this building, this is for 1915 Morris, they were running on oil, right? And if you look in the left column where it says benchmark data, you could see at the bottom that their total fine was $37,468, right? And if you go all the way up to the top, you could see in the benchmark data column, it says to oil KBTU per square feet, and it shows 92.1, right? And then in the OTG, we basically converted that 92.1, made that 0, and added all of that to natural gas, right? And then based on the emissions factors of to oil versus natural gas, it brings down the entire the entire usage of the building. And this building was left with a $4,300 fine. So $33,000 in savings on the fine, right? And again, that doesn't take into account any actual efficiency from replacing the boiler and having a better boiler. So Daniel asked before, um, okay, this is interesting. Also, Christine, you're asking about the supply cost versus transportation. So I could touch on that in a minute. So Daniel asked a question about please cover efficiencies with steam heat. So steam boilers really haven't changed that much for a very long time. Most people, have either a cast iron boiler or a Scotch marine boiler. They all pretty much operate, around 82 to 85% efficiency. What we have been doing a lot of recently is installing 4-pass boilers, which add, so in a 3-pass boiler, basically if your flame comes in from the front, it goes through the boiler 3 times, which allows heat transfer. In a 4-pass boiler, the flame will go through the boiler 4 times. So basically you're extracting more heat from the flame and putting it into the water. So that allows you to get your boiler up to, more like 85, 86% efficiency. And that's on the boiler itself, right? So that's talking about what's called like combustion efficiency. Now, when you think of a system, though, you really have to think about everything that's connected to your system, which is some of the things we'll get into in terms of like heating distribution upgrades, boiler controls, thermostatic radiator valves, because your boiler is making steam, right? Or it's making hot water. Now, where that steam is going to go, where that hot water is going to go, and where you're going to actually lose the heat that you're creating is super important. So I walk around buildings all the time where, they have a basement door open because it's the trash area and they have steam pipes running and there's no insulation on it. So like you're spending a lot of money to heat up outside, right? And you're losing a lot of heat there. Or you might have a building which is really, really, really imbalanced. Like everybody on the A line is super hot and everybody on the D line is super cold. So like you're just running your boiler so that the D line people get enough heat, right? So you really have to look at the whole system, balancing, the distribution coupled with an efficient boiler is really what brings, better efficiency to the whole system.
So I think,
So
do you see John's question at the end about the fact that he can convert to gas? So these items would also work, the efficiencies that you'll discuss later would also work if he's still on oil. Is that?
yeah. So okay, so that was Daniel's question. Daniel, hopefully that was a good answer for you. I see Christine asked a question and then I'll jump to John. So yeah, Christine, transportation costs with Con Ed are very expensive. The way it works, and it depends on the size of your building and how much, how many therms you use. But, for your first few therms, they charge you like $20. And then for your next 87 therms, they charge you like $1.35 per therm. And then for your next like 3,000 therms, they charge you like 95 cents per therm. And then above 3,000, they charge you like 70 cents per therm. So, what we're able to do for you, and other people could do this as well, but you really have to look at your total usage month by month and understand what your costs will be. It is a little bit tricky. They have tariffs that get updated every couple of years, but for smaller buildings, the transportation could be really expensive and it can be twice the cost of the fuel itself. So that's not uncommon. Okay, John, our building looked at gas conversion, but in the end, running the gas to the boiler was not workable based on where the boiler room is in relation to the gas line. So first of all, it's possible. We could help you take a look at that if you want. I've never really run into a building where a gas conversion was impossible, but maybe you're the first. I'd be happy to take a look at it for you. If you're stuck with oil, can efficiencies be achieved? So yes, everything that we're going to cover after the oil to gas conversion section, which is boiler controls, distribution upgrades, all of those things will improve the efficiency of the system as well. From a local law 97 perspective, you're still going to be on oil, right? And the oil number is, about 28% more emittive according to local law 97 than gases. So you're definitely fighting an uphill battle for 2024, and I don't know your exact building, but for 2024, there's a good chance you might be fine. Come 2030, from what I've seen, I haven't seen many oil buildings that are in a good position come 2030. David asks, does it make sense to convert to Con Ed steam? So Con Ed steam is extremely, extremely expensive to operate on. I think from a local law 97 perspective, steam's pretty good, but you're looking at roughly about $4.50 per gallon. So you have to convert from steam, the energy that you would get from kind of district steam to oil, but it's the most expensive out of gas, oil to operate your building on. So from an operations perspective, it usually does not make sense. We have done a few steam to gas conversions. So buildings that had Con Ed steam, we've put in new boiler plants, which is a challenge because sometimes they don't have chimneys. So you have to find somewhere to put the chimney. And a lot of times they don't have that much space for a boiler room. But generally people try and get off of steam because it's very expensive annually.
Right, and they're just figuring out now how and if they can turn it clean. It's gonna be interesting to see what happens with it, I think.
Got it.
Yeah.
Okay, Carla Nielsen. So for pre-war buildings, are you always recommending OTG conversion as opposed to electrification? Confusing. We had a study done through the NYSERDA program where their main recommendation was to use heat pumps individually in each apartment. So I don't think that there's one recommendation, right? You have to really understand what the building's goals are and what you want to do. And there's a lot of benefits to, individual heat pumps, right? I think some of the best benefits, aside from the decarbonization, is that people now have control over their own heating and cooling, right? The downside to electrification generally is it's very expensive. A lot of times buildings don't have adequate electric capacity, so they need to upgrade, which, could cost a lot of money. I mean, I was actually talking to somebody um, who's in this group um, yesterday, and they're looking at costs, like $1 million just to upgrade their service from Con Ed and their service room. So it can be really, really expensive. I think when you go to, programs like NYSERDA, or when you go to, energy efficiency consultants, and the framework of that is what should we do from a local law 97 perspective? They're pretty much always going to come back with electrification because it is the best thing to do from an electrification or decarbonization perspective. The problem is it's very, very expensive. And a lot of times buildings, don't have the funding to do it, or they might not want to spend $1 million or $2 million. And I think, beyond that, the cost of electricity is very, very high. So even when you do electrify, your operating costs a lot of times, especially compared to gas, will generally go up. So you're spending a lot of money. You're going to do really, really well from a local law 97 perspective, but your operating costs might go up. You're not really going to ever have a return on your investment, right? So I think, again, you really have to go back and look at all your options, right? If you're in a fine position where it's $20,000 and you're able to do a gas conversion, and that fine's going to go away in for 2024 and 2030, then you need to electrify, right? I don't think you need to. You still can if you want to, right? And there are benefits to it, but I don't think you have to. Oh yeah, Carla Nielsen, we recently got gas down 181st Street. I'd love to hear what building you're in. We did a lot of gas conversions over there. We did 447 Fort Washington, 454 Fort Washington, 455. We waited a long time for gas over there. Okay, so that's the gas conversion section. Now moving over to this, which is very common, right? And I'll bring you guys back a little bit in history. So 1918 was the Spanish influenza, and millions of people died, and no one really knew what was going on. So everybody's kind of theorizing as to what's happening. And basically, what came out of it is that everybody needs more fresh air, and that they should sleep with their windows open. So what happened was radiators now had to heat rooms with windows open in the winter. This led to really, really, really large radiators. And then the way you size boilers is based on all the radiators that are connected to it. So this led to really, really big boilers, right? Fast forward, nobody really wants to keep their windows open during winter, although we see it a tremendous amount in New York City. And it led to a ton of overheating, right? So we have these control systems like you see on the right, and that one's really old. Most buildings don't have that old anymore. But where you might have one outdoor air temperature sensor, and based on the temperature outside of the building, it's telling your boiler whether or not it should run, which doesn't really make any sense if you think about it, right? Like, what's temperature inside the building, right? Like, if your apartments are 72, your boiler probably doesn't need to run. It doesn't matter if it's 10 degrees out or 40 degrees out or 50 degrees out. If the temperature inside the building is comfortable, then you don't need your boiler to run. But if you have an older style, heat timer system is the most common one. It doesn't really have a great sense of what's going on in the apartments. So a lot of times that leads to overheating, and that's a big, big waste. David Martin said, my building is on number 4 now. I assume it would make the most sense to go to number 2 in gas, correct? So yeah, from a gas conversion perspective, that is what we would recommend generally. We do like, for the most part, to keep oil as a backup. You also have local law 152 going on right now, which is the periodic gas inspection. So a lot of buildings end up having their gas get shut off by Con Ed. So we like having oil as a backup. And then also starting, a couple of years from now, you have to be off of number 4 oil anyways. So even if you didn't want to do a gas conversion, David, the next time probably that your building's triennial comes due, you're probably going to have to do a downgrade to number 2 oil to get that renewed. So if you want to connect after, feel free to call me or email me, but most likely gas and number 2 oil is what I would recommend. Okay, we can move to the next slide. All right, that's fine. My wife's coming down because my daughter left her pacifier and her lovey down here. It's almost bedtime. So we're either going to hear her screaming a lot, or we have to get her what she needs. That's okay. Okay, so as we said before, maximum comfort, minimum cost, right? That's really what we're trying to achieve for our customers' building. So this is just, kind of like a high level explanation. And, I'm sure some of you know a little bit about boiler controls already. But all of these red boxes on the right represent temperature sensors that we actually put in apartments, right? So now what happens is we take a sampling of the building, usually about 25% of the apartments, and we create what's called an average building temperature. And then based on the average building temperature, that will tell the boiler whether or not to turn off or to turn on, right? So if it's 50 degrees outside, but you want to heat your building to 72, and the average of all your temperatures in the building is 72, we're going to tell the boiler not to turn on, right? So we have lots and lots of buildings and data from boiler controls. And, the savings vary greatly based upon how bad your building was performing before the installation. Typically, though, and I know it's a wide range, typically we see about 10 to 20%. We've seen for buildings that are operating really, really well before, sometimes 5%. We've seen buildings that are operating really, really badly, sometimes 30+%, right? So if you have a building that has a lot of windows open in winter, or if you're on the board and you hear a lot of complaints that a lot of people are way too hot, it's probably a very, very good candidate for doing boiler controls. And something that's exciting, the rebates used to only be allowed for buildings that were on gas. Con Ed actually changed that rule earlier. I believe it was earlier this year, that buildings that are on oil are also now eligible to receive rebates for boiler controls. So for like a 50-unit building, you're generally looking at a cost of like $16,000. You get a rebate of about $7,000. So you're looking at like $7,000 or $8,000 out of pocket. And, for a 50-unit building that's on oil, let's say you're doing about 25,000 gallons of oil a year. So maybe you're spending 80 to 90 grand. Even if you save only 10%, you're looking at a 1-year payback, right? So this is kind of what I was alluding to before, like boiler controls just based on itself is a no-brainer. Like you're getting even if it's a 2-year payback, you're getting a 50% return on your investment, right? Which I wish I could just find a way to invest in boiler controls, right? So, this is the concept of boiler controls. And then there's a lot of other ancillary benefits, which is that everything comes online, right? So now we can actually log into our platform, and the building can log into our platform, and you're able to see what's going on in the building. And talking about system efficiencies, like if you have return line leaks, if your stack temperature is too high, these are things that our system will pick up on, will alert both the building staff and us about, so then we could make sure to course correct, right? And part of Local Law 97 and part of, our thesis as a company is that as the city gets stricter, as emissions regulations get stricter, it's not only about setting up the system right at the beginning, because that's the easy part to do, right? What's much more complicated than that is, how's your system running a year later? How's it running 5 years later? How's it running 10 years later? Right. And having the ability to actually continuously monitor that and identify when there are deviations and being able to course correct really quickly helps the building stay on track, because you don't want to find out that at the end of the year, you were 20% over your budget of what you thought you were going to spend, right? So we really want to be able to catch those things as quickly as possible and course correct. So this is a job we did recently, actually very close to Carla. This is at 804 West 180th Street. So here you could see we did a new boiler, we did a new burner, we did a gas conversion. This was actually a 4-pass boiler, which is what I had mentioned before. And then on the right side is the boiler control platform, right? So that's actually in their boiler room. And then, there's an interface both online and in the boiler room. This building got on gas recently, so we don't have a tremendous amount of data yet, but they're very happy so far. Any questions about boiler controls?
Sorry, for some reason this doesn't seem to be. Oh, there we go. Oh, now of course.
Carla asked, how much was the conversion at 804 West 180th Street? Good question. Let's see. Let me look. Can't share this with our competitors though, Carla. So that job was $315,000. And that was a new boiler, that was a new burner, temporary boiler, gas conversion, chimney liner, and boiler controls. Okay, so kind of what I was talking about, trying to be proactive and really understand what's going on, right? Why isn't your service company monitoring your equipment? Why are you waiting for somebody to, wake up in the morning and get in the shower to find out that the water's cold, right? Why are you waiting for somebody's radiator to get cold to hear that you don't have heat? All of these things you're able to pick up on right now in real time. Your boilers are, you know, have all these different components on them that have the ability to give outputs. And with putting in proper systems, we have the ability to accept those outputs, right? And then actually report on them. So the concept is, if there's an issue with the boiler, rather than waiting for somebody to find out a few hours later that, there's an issue, we're able to identify it right away. Now, if you think about the boiler, it's a huge, huge pot of really, really hot water, right? So when it gets a call to turn on, it's usually not like super cold in the building, and you definitely still have hot water. So if you're able to actually catch it when it's first supposed to turn on and start rolling your truck or identifying what the problem is early, a lot of times you're actually able to fix the issue before anybody in the building knows that anything happened, right? So, like I keep kind of saying, maximum comfort, minimum cost, right? At the end of the day, this is where you guys live and these are your homes, and you want to be comfortable in your home. You want to be able to wake up and go in the shower. You want to be able to have heat. So, being able to identify issues quicker allows us to communicate with building staff quicker and, ultimately provide fixes quicker and hopefully, not impact anybody's, comfort at home. Okay, David, so after we convert to gas oil, what do we do when we are supposed to discontinue fossil fuels after 2030? It's a good question. I don't know. I don't know exactly. And I think, you know, it's hard to know what's going to happen over the next 7 years, right? I was talking to Rebecca a little bit before we started, and I think there's a lot of things that need to happen before, the city's going to be able to fully enforce complete discontinuation of fossil fuels. We have a developer in Staten Island who has 7 buildings, and they want to electrify, right? They're getting a lot of funding. It's affordable housing, and they went to Con Ed and they can't even electrify their stoves, right? They have gas stoves, they have gas boilers. There's absolutely no additional electric capacity. So, what do you do in 2030? I don't know right now, right? I think again, I go back to understand what all your options are, understand what the costs of those options are, right? And if you can do something now that brings you into compliance for 2024 and brings you into compliance for 2030 and has a 3-year payback or a 5-year payback, that doesn't seem so risky, right? You lay out 500,000 or 300,000, whatever it might be, but you're getting that money back, right? You're getting rid of your fines. You're making your building obviously more efficient, hopefully more comfortable. And in 2030, if everybody's forced to electrify, then at that point, that's kind of the answer for you. You have to electrify. So now you get into a whole different question. Are you doing VRF? Are you doing packaged terminal heat pumps? Are you doing air source heat pumps? Which, one day we could do a whole nother webinar on different electrification options. Um, but I think it's, for now, in my opinion, gather the information, um, understand what the costs of everything are, understand what the operating costs of everything are. And, you should definitely look into electrification if that's something that your building has the appetite for, right? And we are, like I said before, we are doing electrification projects. We've looked into it with several buildings. From what I can see right now, it's happening a lot more in the affordable world because there's a lot of, government subsidies which are helping to defray the costs. In the private world, a lot of times I've worked with boards and we've looked into it and we run the numbers, and when the numbers come back, it's really hard to get the whole board or enough of the board to vote to actually move forward with it. You're looking at either significant assessments or, figuring out financing and then dealing with your bank. And, is your bank willing to let somebody else come in to do, equipment financing? So it's complicated. Daniel said saving energy on gas and oil is great. Come 2030, moving electric better to my investment in a conversion. To electric better do my investment in a conversion. Or I think Daniel's maybe asking, is it a better investment to go to electric in 2030 than to do a conversion? It's hard to know because you also have to look at obviously the costs of what gas and what electric is at that time. Right now, electric is super expensive. You know, there's obviously like these major large scale, electric upgrades going on, right? I think you have a hydroelectric project coming from Canada. I think you have maybe some wind, some solar, right? And if the grid does get greened, and the electric costs get driven down, then it might be a great investment, to electrify. And it's hard to predict obviously where energy markets will be and where costs will be. Um, so I think keeping your finger on the pulse and understanding where costs are and where energy prices are. I think in my opinion, for the next few years, I don't really see electric costs going down at all. If anything, I see them probably going up. Like Rebecca and I were talking about earlier, they're, talking about taking more plants offline. I think long term, maybe by 2030, maybe after, the hope is that costs do come down. But right now, it's very expensive to operate on electric.
Right. And they have to fund all of these improvements, so they're not going to be decreasing the cost of electric while they're pouring the money into thermal and wind and
Right.
etc. So
Yeah.
yeah.
Okay, so heating distribution upgrades. So I imagine most people here live in a building that has steam, right? So there's one pipe steam systems and there's two pipe steam systems. The top picture on the right over here is something called master venting, right? So what this allows to happen um, in a steam system, you have pipes that are open to the atmosphere, right? All of your radiators have a little air vent on the outlet of the radiator. So when the boiler's running, it makes steam, it's pushing steam through the pipes. And then when your boiler shuts off, air comes back into the system and fills up the pipes. Now, steam and air are both gases, and they can't occupy the same space at the same time. So when your boiler starts, it needs to get all the air out of the system. And the faster you get the air out of the system, the faster you're able to distribute steam throughout your building. So up there is an example of putting in high capacity air vents, which basically eliminates the air from the system really, really quickly. A lot of buildings right now, and we've timed this actually in several buildings, it could take like 10 to 15 minutes from the time your boiler actually makes steam until you get steam to the furthest main in a building, which is a really long time, right? Because you're running your boiler and you're burning gas or you're burning oil during that whole time to make steam, and the steam is moving really, really slowly. So what we typically like to do, depending on the size of the building, is get that time down to 2 to 3 minutes, right? So if you think about it, now your boiler makes steam. Within 2 minutes or 3 minutes, you have steam at the end of the mains. You just save 12 minutes, right? Now, if your boiler cycles, you know, maybe let's say you have 200 days, I don't know, 5, 10 cycles, whatever. Your boiler cycles, 1,000 times a year, or 500 times a year, whatever it might be. And each time you save 12 minutes, you're talking about a lot of runtime, right? So just by doing master venting, you could be looking at, saving 5 to 10% on your consumption, right? And then the nice thing about master venting also is it's not only about getting the air out of the system quickly, but it's also about doing it in a balanced way, right? So this is very, very helpful and is actually the best thing to do in one pipe steam buildings to fix the A line's too hot, the B line is a little hot, the D line's really cold, right? You have to understand how steam moves to be able to kind of manipulate where you want it to go and how quickly you want it to get there. But if we're able to provide a balanced building where everybody's apartment is, receiving steam at relatively the same time, and then you layer that with your boiler controls, now you are starting to create a really efficient system in terms of the distribution, right? Because what I see in a lot of buildings, is you have one or two apartments which are super cold, and those people are complaining, and you have to heat every single apartment, to New York City code, which means if it's below 55 degrees out, everyone inside needs to be 68. So I see buildings where there's apartments that are 80 degrees, you know, and they have to do that just to get certain other apartments up to 68 degrees to be code compliant, right? So if you're able to balance the building a little bit better, now you could run the building at a lower temperature overall. So those two things kind of go really, really nicely together, the boiler controls and distribution upgrades. The other project, which we've done a bunch of, is called thermostatic radiator valves, which basically gives a little bit of individual control within each apartment to your radiators. So this really won't give you more heat, but it can give you less heat, right? So for those buildings that aren't well balanced, and for the people who are opening their windows, you really don't want them to open their window. You lose a tremendous amount of heat when windows are open, right? And that heat obviously is coming from your boiler, which is burning gas or burning oil to create that heat. So putting in thermostatic radiator valves allows you to, essentially say when my apartment hits 72 degrees or when my apartment hits 75 degrees, I essentially want to shut the radiator off, right? So that's what thermostatic radiators valves will do. Um, and that's basically, use that instead of opening your windows. So that's for one pipe steam. For two pipe steam, you get into a little bit more complicated systems. Master venting sometimes still applies, thermostatic radiator valves still apply, orifice plates, some people do, and then steam traps become a very important component of two pipe steam systems. So, a lot of people don't like to do this. Um, it takes a lot of time to really walk the building and understand what's going on with the building. But um, you know, it's very impactful. Alicia Blonsky, I called your company for master venting and pipe installation and was referred out. What size buildings are you interested in helping? So typically the buildings that we help are 25 apartments and up. You can feel free to call me or email me and we could discuss it and maybe we could help you anyways. But I'm sorry that that happened. Any other questions about heating distribution upgrades, master venting, anything like that? My building is a one pipe steam system. We installed TRVs a few years ago and found that they did not work. So, um, okay. I would love to hear more about what was the issue. Sometimes also, so TRVs, depending on what pressure you're operating your building at, they might not work. A lot of people are running their buildings at like 5 pounds of pressure. You kind of have to read the fine print on the TRVs to understand what system it will work for. So a lot of times you have to actually drop your pressure for TRVs to work correctly. If you are running at 5 pounds and your TRVs aren't working, that might be the problem. If there's other issues, I'd be interested to hear what they were. What is the typical cost of doing master venting and TRVs for a 50 unit building? So rough cost for a thermostatic radiator valve is anywhere from like $250 to $300 per radiator. So if it's, one bedroom apartment, you typically have two radiators. If it's two bedroom apartments, you'd have three radiators. So, let's say it's two bedroom apartments, you'd be at 150 radiators. On the high end, you'd be 300 per TRV. So that would be 45,000. And then the master venting, depending on whether you did just the basements or if you did also the risers, you'd probably be somewhere in the $10,000 to $25,000 range. So I'd say for a 50 unit building, you're looking at somewhere between, $45,000 to $75,000, depending on the size of the apartments, how many radiators, how many risers, and if you want to do master venting in the basement and the apartments. Sam can two pipe. Would a vacuum pump accomplish what master venting would? So yeah, if you have a two pipe system with a vacuum pump, then for you, you're not going to be looking at master venting. You're going to be looking at making sure that your steam traps are working really well. Because in a two pipe system, if your steam traps are not working well, your vacuum is just going to be sucking steam essentially out of your supply mains. Um, and it's going to be stealing a lot of steam. And a way to be able to tell that is on your vacuum pump, there's always a vent, right? So on the top of the vacuum pump, there's a vent to the atmosphere, which is where all the air leaves, right? Which is, I think, what you're referring to. Would a vacuum pump accomplish what master venting would? So the answer to that is yes. If you see steam coming out of the pipe on top of your vacuum tank, then that might mean, and it almost definitely means, that your steam traps have failed. So in that case, you want to be able to identify which traps have failed and replace those traps because that wastes a lot of energy. Okay. So that is about heating distribution upgrades. That's the end of the presentation. Thank you guys for having me. If you have any other questions, I'd be happy to stay on and answer them.
Does anyone have any other questions for Steve? All right. Well, thank you so much for joining us. And I guess you can, we'll distribute the slides. It's okay with you, Steve, right?
Yeah, absolutely. And I will post my information in the chat.
Excellent. And I'll forward that out with the slides. So if any of you want to get in touch with Steve with additional questions, you can do that. All right.
Perfect.
All right. All right. Thank you so much. All right.
Thank you so much for having me, and hope everybody has a great night.
Great. All right. Good night,
Take
everybody.
care.
Bye.
Bye.